Welcome to DevOps and the SDLC. This integration streamlines your workflow from planning to deployment, automate processes, and boost reliability. Let's dive in.
Have you ever stopped to wonder how the apps you use every single day go from just a messy idea to a polished product that lives on your screen? Well, I can tell you it is definitely not magic. It's a structured process, a kind of blueprint designed specifically to turn all that chaos into clean, working code. And today, we're going to break that blueprint down. But, before we get to the solution, let's talk about the problem. We've all seen the headlines, right? A massive software project, years in the making, finally launches, and it's a complete disaster. It's way over budget, months late, and it doesn't even do the one thing it was supposed to. So why does this happen so often? The signs of a project that's spiraling into chaos are, well, they're painfully clear. The final product is missing key features, the budget just balloons out of control, the code is absolutely riddled with bugs, and maybe worst of all, the people it was built for are left totally frustrated. It's a true development nightmare. So how do you actually prevent all of this? Well, you need a plan, a blueprint. And in the software world, that blueprint is called the Software Development Lifecycle, or SDLC for short. It's the framework that's designed to bring order and predictability to what can otherwise be a really complex and, frankly, chaotic process. Okay, so what is it exactly? The SDLC is a structured framework that breaks down the entire process of building software into a series of clear, well-defined stages. You should think of it less like a simple recipe and more like an architect's master plan, something that guides the team from the foundation all the way to the finished building, making sure nothing critical gets missed along the way. And this blueprint, it directly tackles the chaos we were just talking about. It provides visibility, so everybody from the investors to the developers knows what's going on. It forces teams to build quality control in from the very start, not just tack it on at the end. It helps manage risk by spotting potential problems early, and that leads to much more accurate estimates for both time and money. All right, so what does this journey actually look like in practice? Let's walk through the typical stages of the SDLC. This is the step-by-step path that turns that first spark of an idea into a polished, working piece of software. And here they are, these 7 core stages of the life cycle. It starts with planning and goes all the way through to long-term maintenance. Each of these stages has a very specific purpose, and each one builds on the one that came before it. So let's break them down. Everything kicks off with stage 1, planning. Now, this is arguably the most important step of all. Before a single line of code gets written, the team has to ask the tough questions. Can we actually build this thing? Does it make any financial sense? Do we have the right people and the right resources? The result of all this is a high-level project plan that really acts as the foundation for everything that follows. Once the project gets the green light, we're on to stage 2, defining. The goal here is to get incredibly specific. What exactly should this software do? Every feature, every function, every little constraint gets documented in a super important file called the Software Requirement Specification, or SRS. Now, to give you a sense of just how important this document is, you just need to know what developers call it, the Bible of the project. Seriously, it becomes the single source of truth that guides every single decision. The rule is simple. If a feature isn't in the SRS, it doesn't get built, period. So with the what all decided, Stage 3 focuses on the how. This is where the system architects and senior developers step in. They translate that SRS document into a technical blueprint. They map out the software's architecture, they design the database, and they plan exactly how all the different pieces are going to talk to each other. And now we get to stage 4, development. This is the phase that most people picture, right? The heads-down coding part. It's usually the longest stage, where developers take those design blueprints and translate them into thousands and thousands of lines of functional code, building the actual product piece by piece. But once the code is written, it is nowhere near ready for the public. Nope. It moves on to stage 5, testing. This is where the quality assurance, or QA team, takes over, and their mission is absolutely critical. Find and report every single bug, glitch, and broken feature before it ever gets into the hands of a real user. So, after all that rigorous testing and bug squashing, it's finally time for the big moment, stage 6, deployment. This is launch day. The code gets pushed to live servers, the switch is flipped, and the software is officially released out into the wild for customers to start using. But the work is not over when it launches. Oh no. The final stage, maintenance, is ongoing. Software is never really done. The team keeps fixing new bugs that pop up, they improve performance, and they add new features based on what users are asking for. This is what keeps a product alive, relevant, and useful over time.
So that's the 7-stage journey, but here's a really key detail. It's not a single, rigid path that every project follows in the exact same way. It's more of a flexible framework, and different projects and different teams adapt this blueprint using different models.
And really, two main philosophies have emerged. You've got the traditional waterfall model, which is strictly linear. You have to completely finish one stage before you can even think about starting the next. And then, in contrast, you have agile models, which work in these small, rapid cycles, building and testing the software piece by piece. This allows for requirements to change and evolve as you go. The difference really boils down to one word: flexibility. With waterfall, you only get feedback from users at the very end, which makes changes late in the game incredibly expensive. But with agile, that feedback is continuous, so the cost of making a change is much, much lower. If your project's needs are totally fixed and you know they won't change, waterfall can work. But for most modern software, where things are expected to evolve, agile's definitely the go-to choice. Okay, let's try to make this a little more concrete. How does this blueprint apply to something we all know, like, say, a new mobile banking app?
Well, you can see the key stages in action. It all starts with planning and defining, where stakeholders and analysts figure out precisely what the app needs to do. Then comes design and development, where the team builds the screens you see and all the secure logic on the back end. And finally, of course, that critical testing phase where everything is double and triple checked to make sure your money is safe before it's deployed to your phone's app store.
The thing is, the SDLC itself is constantly evolving. And the biggest evolution in recent years has been driven by one critical factor that just can't be an afterthought anymore: security.
Here's the fundamental shift. The old way was to treat security like a final checkbox, something you did right before launch. This was slow, it was expensive, and honestly, it was incredibly risky. The new way, which is often called DevSecOps, is all about building security into every single stage of the process, from the initial planning all the way through deployment and maintenance.
This modern philosophy has a simple name: shift left. Just picture the SDLC as a timeline from left to right. This means moving security from the far right end of the process all the way over to the very beginning. It's a fundamental change from being reactive to being proactive. Because, let's face it, finding a flaw in the blueprint is infinitely cheaper than having to recall a finished product. So, from managing chaos to writing clean code, the SDLC is the essential framework for building reliable software. We've seen it evolve from rigid, linear models to flexible, agile ones, and now to a security-first mindset. This really leaves us with one final thought. As software becomes even more deeply embedded in everything we do, how will this blueprint need to evolve next?